Assalamu alaikum. Good evening, students. My name is Zishan Akbar from Civil Engineering Academy. Before starting my topic, I want to request you that please subscribe my channel and press the bell icon so you can get the notifications for my newly uploaded videos. Thank you very much. Today I am going to discuss the fixed beam, a beam which is fixed at one end, not a completely fixed beam, but a beam which is fixed at one end, or the other name for this beam is cantilever beam. What is a cantilever beam? Basically, a cantilever beam is a beam in which one support at its one end is fixed while the other end is free. So in this figure we can see that there is a beam. This is horizontal member is beam. It's fixed. It has a fixed support at its one end and the other end is free, or we can rearrange this beam and we can shift this fixed support to right side and the left side will be free. So basically the cantilever beam is a beam which has a fixed support at its one end and the other end of the beam is free. So simply this is a cantilever beam. So in cantilever beam, because there is only one support which is a fix, so fixed support has three restrictions or three unknown reactions. These unknown reactions are known as, one reaction is Rx, which is in horizontal direction. One reaction is Ry, this is also unknown, it is in vertical direction, it may be upward or downward. This Rx may be rightward or leftward. And the third and the last unknown reaction in this beam is a moment reaction, because this beam does not allow this beam, this support does not allow this beam to rotate about itself in clockwise or anti-clockwise direction. So we have total three unknowns. First one is Rx, horizontal reaction. Second one is Ry, vertical reaction. And the third one is moment M, that is moment reaction. Because we have three unknowns and we have three available equations of equilibrium, summation of forces along x-axis is 0, summation of forces along y-axis is 0, and the important term, important change which we will see here, that is, in previous cases we have been studying that summation of force at any point A or B is equal to 0, but in this case or in this specific example where we encounter a fixed support at one end of the beam, then the moment will never be equal to 0, because here there is a moment reaction that we call it as M. So summation of moments at support A, so suppose we call this as A or this as A. So moment reaction at A will never be equal to 0. This will be equal to some value. Suppose we can say that summation of moments in this beam is equal to MA or MB or MC, whichever the sign you assign to this fixed support. So summation of moments about this point will be equal to MA but not equal to 0, because in fixed support has three reactions and it also resists moment. In roller support or in pin support there is no resistance to moment. That's why in the previous examples we have been writing as summation of moments at point A is equal to 0. But in this case, in this specific case, it is not equal to 0, it is equal to MA, because we have some moment value at point A or at a point which is connected with the fixed support. So to study these things, to determine the reactions of a cantilever beam loaded with a complex loading, because previously we have been discussing point load or UDL or GVL, but in this case I am going to discuss all types of loads which we have discussed in previous examples or previous questions. So in the first attempt I have taken the gradually varying load from 0 to an intensity of 100 kN per meter and a UDL with a uniform loading of 50 kN per meter and a point load at the end point of the beam, that is 50 kN. So the first step in this solution is to convert this GVL, gradually varying load, into point load and then determine the location of that point load from this point of zero loading. So our first step is converting W's into P's. This W and this W will be converted into point load. So for this one, GVL, we studied in the last lecture that we simply calculate the area of this triangular. How the area of triangular is calculated? Half of the weight, that is distributed load, multiplied by the length along which the load is acting. So the length is this one. From this point to this one is the length along which the W1 GVL is acting. So this is 10 meter in this case. So 1 by 2, half of 100 multiplied by this is 100 W1 and length 1 is 10 meter. So we will multiply and simplify this as Pgvl equal to 500 kilonewton. So our point load from gradually varying load is 500 kilonewton simply. Then we want to know the distance of, suppose this point load acts somewhere here. So distance of this point from this zero load point will be, as we previously discussed, this will be equal to 2 by 3 L1, because this is span length of load W1, and so the P1 or Pgvl, this Pgvl will act at a distance of 2 by 3 of L1. So 2 by 3 of this L1, 10 meter, becomes equal to 6.67 meter. So distance of this point from this point will be equal to, from this to this point will be equal to 6.67 meter. I have shown this distance on the next figure, as you can see here on this page. See here, this is triangular loading, this is 0 point load, this is maximum point load, that is 100 kilonewton per meter. We have converted this Pgvl on the last page equal to 500 kilonewton. So this 500 kilonewton load, we can write it as 500 kilonewton. This 500 kilonewton load will act from at a distance of 6.67 meter from this 0 point load, because in our question this 0 point loading is merged with the fixed support at point A. We are supposing this as point A. So at this point A is coinciding with the point of zero loading. So this point and this point are 6.067 meter apart. So we have found, we have nominated this as x1, 6.67 meter. And so finally, the P gradually varying load, the point load from GVL is 500 kilonewton and its distance from the fixed support or 0 point load is 6.67 meter. So our next step is to convert this UDL into point load and to find out its distance from the fixed support. So it will be like this. For UDL, we have to calculate the area of this rectangle. What is the area of the rectangle? Length into width. What is length of the loading? 5 meter, and what is width is 50 kilonewton per meter. So in our case, the PUDL is equal to W2 L2. W2 is 50 kilonewton per meter and L2 is 5 meter. So when we multiply 50 with 5, that will become 250 kilonewton. This meter will be deleted with this meter. Now the distance of UDL point load from a point or fixed support is x2. We are supposing it as x2 from this point to at midpoint, because the UDL point load acts at the midpoint of this rectangular load. So the whole span of the rectangular load is 5 meter. So this point load PUDL will act at a distance of 2.5 meter from either end. From this end it is at equal to 2.5 meter, L2 by 2, and from this end this is also L2 by 2, that is 2.5 meter. So we want to determine x2, that is equal to, x2 means from a point to the point where the PUDL is acting. So this will be L1 10 meter, next 5 meter, the span which has no load, and L2 by 2. Here L2 is 5 by 2. So 10 plus 5, 15, plus 5 by 2, 2.5. This means 2.5. So 15 plus 2.5 will be 17.5 meter. So the distance of UDL point load from fixed support is 17.5. So I have shown all these distances on this free body diagram of the beam. This is also known as FBD of the beam. Now we have to apply the equations of equilibrium. First equation of equilibrium is summation of forces equal to 0, and this sign shows that rightward forces along the x-axis are taken as positive. So this AX is taken along positive x-axis, and AX, there is no any other force in that direction, so it will become 0. We have got AX as equal to 0. So our next equation of equilibrium is summation of forces in y direction 0, but upward forces will be taken as positive. So simply AY is acting upward. We supposed that AY is acting upward, so AY will be positive. 500 is acting downward. This is Pgvl, mean a load which is obtained from gradually varying load conversion to point load. That is 500 acting downward. This will be minus. UDL point load is acting downward. It will be negative 250, and P point load is acting already in downward direction, so it will be minus 50. If we add all these values, this becomes minus 800, and we will shift these all values to the right side of the equation, and it will become plus 800. So AY is plus 800 kilonewton and is acting upward in upward direction. So we have found AX equal to 0, AY is equal to 800 kilonewton. So last thing which is remaining is MA. Because this MA is acting in clockwise direction, so it will be treated as negative, and anti-clockwise moments or counterclockwise moments are taken as positive. It is on the left side of the beam, so these are on right side of the beam. Simply we can say that a moment of this beam are caused by these three loads will be equal to MA. So MA is resistive moment, so we can take as that, we can write it as plus equal to 0. We can write for this beam, for this specific beam, as I told earlier that this will not equal to 0, but if you are adjusting this MA on the sides of the loads, on that side of the equation which is for loads, specifically for the loads, so we can write it as summation of moments at MA is equal to 0. But in other case you will write summation of moments at A is equal to MA, and sign of MA will depend upon your assumption. If you are assuming in clockwise direction, it will be negative, and if you are assuming in anti-clockwise direction, it will be positive. So as we assumed in this case in clockwise direction, so it will be negative MA. So Pgvl into its moment arm. What is Pgvl? 500 kilonewton. Its moment arm is x1 6.67 meter. This term is confirmed. Pudl is 250 kilonewton and its moment arm is x2. Moment arm mean distance from support, fixed support to this load point, that is 17.5 meter. And what is P? This is 50 kilonewton. And what is distance of P from fixed support? That is overall length of the beam, because point load P is acting at the end point, at the free end. This is free end of the beam, so P load is acting at the free end of the beam, plus MA. This MA is also considered in clockwise direction, so we will add this to all these moments equal to 0. Simply this plus MA will be shifted to other side and it will become minus MA. Pgvl is 500, its moment arm is 6.67, plus Pudl is 250, its moment arm is 17.5, P is 50 and its moment arm is 22. So when we calculate using calculator product and sum of all these values, it becomes 8808.33 kilonewton meter. So this is unit. So this is moment, because moment is equal to F into D, and unit of force here is kilonewton and displacement or moment arm is meter, so unit of moment is kilonewton meter. So this negative sign is shifted to this side, this becomes negative. This negative sign shows that our assumed direction for the moment at A is wrong. Is wrong mean we have to suppose it in opposite direction. We supposed it in this direction, but in real case this is in this direction. This moment is originally anti-clockwise. So we can show the new free body diagram for all these solution. AX 0 kilonewton, AY as 800, and MA is equal to minus 8808.33 kilonewton on this figure. This is solved free body diagram with original load values and support reaction. So original load was triangular load or GVL. This is equal to 100 kilonewton per meter. The second load was UDL, uniformly distributed load, with an intensity of 50 kilonewton per meter, and a point load of 50 kilonewton was acting at the free end of the beam. So this was point A. Here there was a horizontal reaction, that was 0. Vertical reaction, that was 800 kilonewton in upward direction, and we assumed the direction as clockwise for MA, and we got at the end that MA with negative sign. It means that our assumed direction is wrong. We have to write in the final free body diagram it as in counterclockwise direction. So our MA is basically written as in counterclockwise direction, and its value is 8808.33 kilonewton meter. So I finally wrote the reactions of the fixed support, that is horizontal reaction as 0, vertical reaction as 800, and moment at A equal to 8808.33 kilonewton meter in counterclockwise direction. So basically our moment is in counterclockwise direction, not in clockwise direction. This negative answer make the idea clear that our assumed direction of MA in clockwise direction is wrong. We have to reverse the direction, but we will not reverse it here. We have to reverse in the final answer, in the final free body diagram. When we have calculated all the things, then we will reverse the direction of the MA. Not in the middle of the question you will change the direction of the moment. You will change at the end. Before the final diagram, before this diagram, you will use the same direction of MA as assumed here, but here it will be shown in counterclockwise direction. Thank you very much. Kindly I request again to subscribe my channel and press bell icon so that you can get notification of my newly uploaded videos.